Hello, everyone. My name is Anindya Day. So welcome to the series of lectures on the Myhill-Nerode theorem. Uh, a little bit about me. So I'm currently an assistant professor in computer and information science at the University of Pennsylvania. And in the past, I was on the faculty at Northwestern. Before that, I did my postdoc at the Institute for Advanced Study and TIMAX. Before that, I finished my PhD from Berkeley in 2013. And I finished my undergraduate studies in India, which is where I grew up. So my current research mainly focuses on the role of randomness in computation. And increasingly, of late, I have also been looking at the mathematical foundations of inference, learning, and broadly speaking, statistics as well. Um, so the reason I am in theoretical computer science, well, there are many, but maybe above all, the reason is that I believe computation holds a fundamental promise as a lens to look at every other science. It's a way of understanding how, in a bottom-up fashion, simple processes can give rise to very complicated phenomena. And towards that, I believe theoretical CS is a very foundational way of understanding these processes. Coming back to the agenda for the series of videos, uh, so the goal of this series of videos is oops, the goal of the series of videos is to provide a syntactic characterization of the class of regular languages, which you have already seen in the previous lectures. What I mean by providing a syntactic characterization will be that we will, so far, when we have discussed regular languages, we have seen this as a class of languages which are accepted by a finite automata. But you'll see like there's an entirely different way of talking about regular languages, which does not at all make any reference to a finite automata. And this will be the goal of the Myhill-Nerode theorem, which will prove in this series of lectures. And then the Myhill-Nerode theorem will also give us a way to compute the best DFA, the smallest DFA for any regular language. Okay, so this, in other words, given there's a regular language, will show how there's a unique best DFA to compute that language, and also a way to find such a DFA. And so as an outline for the rest of these videos, the first one was this video, the introductory video. In the next video, I will talk about equivalence relations. So this is a very basic kind of mathematical object in set theory, and which you might have encountered in discrete math before. So I'll recall the basics of equivalence relations and what we need of them. And the goal of the third video would be to prove the so-called Myhill-Nerode theorem, in which we'll heavily use the notion of equivalence relations. And the fourth video will use the Myhill-Nerode theorem, or rather the tools that we will introduce to prove Myhill-Nerode theorem, in order to give an algorithm which, given any DFA, will find out the smallest DFA which accepts the very same language. So that will be our agenda. So thank you.